Hello and welcome. Every single time you click a link or stream a video, that signal travels through a piece of hardware that most of us never even think about. Well, today we're going to change that. We're pulling back the curtain and demystifying the network switch, the powerful blinking box that literally makes our digital world go round.
I bet you've seen these before, right? Tucked away in a server closet, just humming away. A whole wall of metal and blinking lights. They're pretty much the unsung heroes of the internet. But have you ever actually stopped and wondered, what's really going on inside one of these things?
Well, at the center of this whole universe is the network switch. The best way to think about it is like the ultimate traffic cop for all of your data. Every email you send, every video you watch, every website you visit, it all gets intelligently routed through a switch just like this one, and it gets to where it's going in a blink of an eye.
So, to really understand how it all works, we've got to crack it open and look inside. So let's start with a little anatomy lesson, a tour of the physical parts that make this device so tough.
First up, let's talk about power. You'll almost always see at least two power supplies. Why two? It's all about redundancy. If one of them fails, the other one just takes over instantly, so your network never ever goes down. They're also what we call field replaceable, which is just a fancy way of saying an engineer can hot swap a bad one without shutting anything down. Pretty cool, right?
Now, all that data crunching generates a whole lot of heat, and that's where these fan modules come into play. And just like the power supplies, they use what's called 1+1 redundancy. Basically, one is enough to get the job done, but there's a backup ready to kick in immediately if the first one has a problem. It's all about maximizing that uptime and reliability.
Okay, so that's the back of the switch, all about power and staying cool. Now, let's flip this thing around and look at the front, because this is where the action happens. This is where all the data flows in and out through the ports.
And whoa, would you look at that, there are a lot of them. These are the access ports, and it's where you plug in all your everyday devices. Computers, printers, servers, you name it. Those labels you see, like 1000 base T or 10G base T, that's just telling you the speed they support, from your standard gigabit all the way up to super fast 10 gigabit connections for the really heavy-duty stuff.
So you've got all these standard ports for your local devices, but what about connecting this switch to another switch, or hooking it up to the rest of the internet? For that, you're going to need something a little more flexible. And that's where these uplink modules come in. See, these are special slots that can take different kinds of high-speed connectors. We usually call them SFPs, which stands for Small Form Factor Pluggables. This modular design is absolutely key because it lets the switch connect to all sorts of different networks using different kinds of cables. Now, don't let the small size fool you. You might look at an SFP and think, oh, it's just a simple plug. No way. It's actually a tiny, super sophisticated piece of hardware all on its own. It's packed with complex stuff like laser drivers and amplifiers. It's practically a mini computer that's dedicated to just one single connection. And they basically come in two main flavors. You've got optical SFPs, which use lasers to send data as pulses of light over fiber optic cables. These are perfect for covering huge distances. We're talking kilometers here. Then you have copper SFPs, which use the good old electrical signals over standard Ethernet cables for shorter runs, like connecting switches that are in the same room. Okay, so we've toured all the hardware, but how do you actually talk to it? How do you configure it and tell it what to do? Well, that all starts with making a physical connection. It's like your first digital handshake with the machine. Getting that first connection usually boils down to 4 key steps. First, you need a special cable to link your laptop to the switch's console port. Then, on your computer, you have to figure out which port that cable is using. After that, you use a terminal program to open up a direct line of communication with the switch's brain, and then you're in. The first thing you've got to do on your computer is find out what communication port your adapter's using. If you're on a Windows machine, you'll find this in the Device Manager. But don't worry, every operating system has a similar tool to see what hardware is plugged in. So, in your system's hardware list, you're going to find the adapter listed under a port name, usually something like COM followed by a number. That number is the specific address your computer uses to talk to the switch, so you'll definitely want to make a note of it. All right, last step. You open up a terminal application. PuTTY is a super popular one, and it's free. You tell the software you want to make a serial connection. You pop in that COM port number you just found, and you set a standard connection speed. Once you hit connect, boom, you're in. You are now talking directly to the switch.
Okay, so you're connected. Now what?
Well, now you get to start speaking the switch's native language, and that is done through something called the command line interface, or what everybody just calls the CLI.
You know, interacting with the CLI is kind of like having different security clearances. You start off in a basic read-only mode. From there, you can type enable to move up to a privileged mode where you can see all the detailed info. But to actually make changes, you have to enter a special configuration mode. And see how the little prompt on the screen changes? That's to tell you what level of access you have at any given moment.
So we're connected, and we know how to move between the different access levels. Let's use our newfound power to do something really useful. Let's run a basic hardware health check.
And we're going to start with one of the most fundamental and useful commands there is, show inventory. The show inventory command, it gives you a complete list of every single physical component the switch can see, from the main box itself to every single SFP you have plugged in. It's the very first place you look to see if a part you just installed is even being detected. Other commands, like show environment, check vital signs like temperature and fan speeds, while show version confirms your software and tells you how long the device has been up and running. Now, when problems do pop up, it's often a physical issue, a faulty power supply, or an SFP module that's not being recognized. So the universal first step in hardware troubleshooting is to simply reseat the component. As network engineers always say, just jack out, jack in. Seriously, this simple action can fix a bad connection and force the system to see the hardware again. You would be amazed how often that actually works.
So there you have it. In just a few minutes, we've gone from looking at a mysterious blinking box to understanding its core components, its language, and even how to check its pulse. The next time you see one of these devices, you won't just see blinking lights. You'll see the redundant power supplies keeping it alive, the modular ports giving it flexibility, and the command line just waiting for your instructions. You'll be looking at the very heart of our connected world.